Back in the Cenozoic era, the mellistiferous mammal Kolponomos, or a marine bear living in nearshore environments, thrived on hard-shell sea vertebrates. Before Kolponomos' discovery, only suction feeding and shell crushing were known feeding mechanisms that mammals used to consume similar food in the carnivorous fossil record. The skull anatomy of Kolponomos, however, resembles the canine shearbite model of saber-toothed predatory behavior. In this model, the anterior mandible functions as an anchor to kill for the saber-tooth, but a tool for shell prying for Kolponomos. In both species, we see vertical orientation of the mandibular symphysis and deepening of the anterior jaw. Researchers hypothesized that Kolponomos and the saber-tooth converged on using their anterior mandibles. In Kolponomos, neck musculature was emphasized to provide high torque caused by the fulcrum created by the mandible's anteroventral surface to help incisors dislodge prey bound from hard substrates. Interestingly, Kolponomos also utilized broad occlusal surfaces to crush hard-shelled prey, similar to the bivalve crushing of sea otters. However, through experimentation, researchers expected to find similarity in high mandibular stiffness required for deformation-resisting structure.
For this study, researchers at the Museum Microscopy and Imaging faculty used high-resolution microcomputed tomography to scan Kolponomos and 6 other carnivores: smilodons, sea otters, brown bears, leopards, and gray wolves. Then, image segmentation and digital separation of the mandible from the craniums were performed. Following this, surface meshes were cleaned and solid meshes of all species were generated. Finally, finite element analysis software was used to conduct 2 sets of analyses. The first stimulated anchor bites. This consisted of forces proportional to the estimated muscle attachment area and bite points that are located at the tips of both canines. The second stimulated mastication bites, where researchers looked at how efficiently the animals could perform various bites. This includes jaw-anchored killing shear bites that is characteristic of saber-toothed cats. From this, they compared the mandibles of 6 other carnivores, including species representing a broad phylogenetic sample. The researchers hypothesized that these species will display similar feeding strategies. Using finite element protocol for comparative functional analyses of the skull structures, the researchers estimated mandibular mechanical efficiency, strain energy, and von Mises stress distributions. Lastly, using 3 geometric morphometric, they analyzed shape similarity of mandible among sample species and areas where the bones are joined together in the lower jaw.
This graph represents the ratio of strain energy to mechanical efficiency of simulated anchor bite prey acquisitions of the test subjects. As you can see, Kolponomos is quite similar to Smilodon ratios. The Kolponomos ratio is also similar to that of one of its closest relatives, the brown bear, which is to be expected. Upon simulating anchor prey acquisitions, the dorsoventral displacement ratios of the mandible for the test subjects at 5 locations can be seen here. Once again, Kolponomos, represented by the star, and Smilodon, represented by the white triangle, are fairly similar in that they both have the lowest displacement to mandible length ratios. The brown bear, represented by the black circle, exhibited much higher displacement ratios. This graph also represents the ratio of strain energy to mechanical efficiency. However, these results depict simulated mastication rather than prey acquisition. The results are similar to prey acquisition, with the ratio of Kolponomos lying between the ratios of Smilodon and the brown bear. Using the other data, the researchers were able to create dendrograms representing the relationships between Kolponomos and the other test species. In both prey capture and mandibular shape, Kolponomos was found most closely related to Smilodon rather than its closest relative, the brown bear.
So the reason the researchers found that the Kolponomos was closest in jaw structure to the Smilodon rather than its closest relative, the brown bear, is because of convergent evolution. It was evolutionarily advantageous for both Kolponomos and Smilodon to have the same jaw structure. In evolutionary biology, convergent evolution is a process where unrelated organisms independently evolve similar traits as a result of having to adapt to similar environments
created using Powtoon.